Welcome to today's explainer. So, today, we're looking at something that is literally everywhere, yet it's totally biologically extraordinary. Think of a seed as this tiny, sleeping hero, just waiting to embark on an incredible journey of transformation. Seriously, it holds immense potential locked away in a tiny little vault, just waiting for the absolute perfect moment to wake up. Okay, let's dive into this. Have you ever wondered how a seed weighing, say, 30 kilograms actually grows? No way, right? Well, believe it or not, the Earth's largest seed is the coco de mer, and it weighs in at a massive 15 to 30 kilos. To put that into perspective, it's kind of like planting a medium-sized dog. It's hard to imagine something that heavy sprouting into a plant, but the biological mechanics behind how it wakes up and grows, they are exactly the same as those tiny mustard or cumin seeds you've probably got sitting in your kitchen right now. Here's our roadmap for the journey today. We'll peek inside the seed, uncover the magic growth factors, look at the stages of seed germination, and finally, wrap up with the great seed dispersal. Section 1. Inside the seed, the sleeping hero. Now, before our hero can go on a quest, it needs some armor. For a seed, this armor is the seed coat, and it protects the super delicate inner parts from any external damage. This coat is actually made of two distinct layers. You've got the tough, exposed outer part called the testa, and a thin inner membrane lying right underneath it, known as the tegmen. Together, they keep the whole shebang perfectly safe. Once we get past that protective armor, we find the embryo. This is the actual baby plant. It lies safely nestled between the fleshy parts of the seed, which are called the cotyledons. Think of these cotyledons like a fully stocked pantry. They are packed with stored food, mostly starch, providing all the vital nourishment our hero needs for the journey ahead. The embryo itself has two main parts. First, the plumule, which will eventually shoot upwards to become the plant's stem, and second, the radicle, which pushes downwards to become the root. You see, the embryo relies entirely on that pantry of stored food until it's big enough to grow its own leaves. Now, what's really interesting about this is how scientists actually categorize these seeds based entirely on those food-storing leaves, the cotyledons. If a seed has just one seed leaf, it's called a monocot. Monocots include your everyday staples, wheat, rice, and maize. But if it contains two seed leaves, it's a dicot, or dicotyledon. Good examples here are groundnuts, mangoes, and peas. It's a fairly simple structural difference, but it's an absolutely fundamental one in plant biology. Section 2. The magic growth factors. Awakening the seed. So, we have our sleeping embryo packed with food, right? But it can't just stay dormant forever. To actually achieve germination, it needs some very specific environmental triggers to wake up. It doesn't just happen randomly in the soil. The crucial point here is that there are three essential growth factors: water, air, and warmth, and these are absolutely non-negotiable. First up, water. The seed coat absorbs water, softens up, and lets moisture reach the embryo so it can finally use that stored food. Second, it needs air. Germination takes a lot of energy, and air provides the oxygen the baby plant needs to actually grow and develop. And finally, warmth. Sunlight provides the right temperature, usually between 25 and 30 degrees Celsius. If it's too hot or too cold, it can literally destroy the embryo before the journey even starts. To prove just how critical these factors are, let's look at a classic beaker experiment. Picture 3 seeds on a piece of cardboard, dipped halfway into a beaker of water. Seed A sits at the very top. It gets plenty of air, but absolutely zero water. Seed C is totally submerged at the bottom, getting all the water it could ever want, but no air. Both of those seeds are going to fail. But seed B, sitting right there at the waterline, it gets enough water and enough air. Seed B is the only one that thrives. It's like a perfect biological lock and key. Missing even one factor stops the entire process cold. Moving on to Section 3, Stages of Seed Germination, the Transformation. Let's see how this builds, step by chronological step. This is the ultimate transformation from a hard little object into a living, breathing seedling. Step 1, the seed is sown in the soil and moistened. It gets watered daily so that hard coat can easily break down, all while soaking up air and warmth. Step 2, the seedling actually breaks right through that softened coat and emerges, getting its very first meals straight from those cotyledons we talked about earlier. Step 3, the seedling pushes its roots downward and shoots upward. And finally, Step 4, it develops leaves and branches. And this is a real game changer because once those first leaves form, the stored food inside the seed is officially gone, and the plant has to start making its own food using the sun. In our final section, number 4, the Great Seed Dispersal, the final quest. Now that we know how they grow, we hit a pretty major dilemma. Plants are completely stationary. They can't just get up and walk to a new home. If a plant dropped all its seeds straight down, those new seedlings would be totally crowded, fiercely competing with each other and their parent for sunlight, nutrients, water, and space. So, plants had to get clever. And this brilliantly illustrates the incredibly diverse agents seeds use to travel and scatter far away. Some just catch a ride on the wind. These seeds are super small and light, or they have hairy, parachute-like structures. Think of dandelion or cotton seeds floating away. Others use water. The lotus has spongy fruits, and the coconut has these trapped air fibers that basically act like a life raft, floating on ocean currents to distant shores. Then we have animals. Seeds like xanthium have literal physical hooks or spines that snag right onto animal fur. Or they're hidden inside juicy, fleshy fruits like apples or mangoes, getting carried off and dropped by animals after lunch. And finally, my personal favorite, explosion. Some plants, like peas or balsam, have fruits that dry out and literally burst open with immense force, shooting their seeds several feet away. Talk about making an exit. To wrap up today's explainer, I want to leave you with a really fantastic explosive fact. Popcorn kernels? Yeah, they are actually seeds of maize plants, and they use a very similar explosive mechanic. They explode upon being heated. It's just wild to think that the same explosive mechanics driving plants to spread across the globe are happening right inside your microwave on movie night, which leaves me with a final thought for you to ponder. The next time you step outside, just take a look around. What incredible journey do you think the seeds in your very own backyard are embarking on right now? Thanks for exploring this amazing biology with me, and keep learning.